whatever it is, just make sure that you're participating and asking questions throughout the entire review. Let's get started. I'm kind of going through the test backwards. Okay, so I think this would have been like the last question on the test. I'm going over it first. The figures shown below all have circular bases with a radius of r units. The 4 figures have equal heights. Which figures, if any, have equal volumes? So let's actually realize what's going on here. They all have the same radius. So all of them have basically this. If they all have the same radius, then the base would be the same for all of them. The base would be the same, and they all have the same height. So the height is the same for all of them. So thinking about what actually is going on here, let's do this. Do they all have the same volume, or do they maybe all have slightly different volumes? So Perla says no, they do not all have the same volume. The cone is a third of the cylinders. So let's kind of one more time just review what's going on here. The base would be pi r squared, and it's going to be the same base for all 4 of them. The height is the same for all 4 of them, but the volume formula is different depending on the shape, right? So the top one, volume equals 1/3 BH. And for my cylinders, what's the volume formula? Just base times height, or in other words, pi r squared height. This is 1/3 pi r squared height. So even though they have the same radius, they have the same height, even though the bases are the same, the heights are the same, these 2 are cones and these 2 are cylinders. So the formula is slightly different, which means that they're not all going to have the same area. But what about 1 and 2? Will 1 and 2 have the same area? Yeah, why? Or volume, not area. Cavalieri's principle. Cavalieri's thingy. So 1 is going to be equal to 2 because of Cavalieri's principle. See, even I struggle with this. Cavalieri. What about 3 and 4? Well, these have the same volume. They will also, because of Cavalieri's principle. So even though they don't all have the same volume, 1 and 2 are going to be the same, and then 3 and 4 are going to be the same because both of these are cones and both of these are cylinders. And even though one of them is leaning over and the other one's not, we know that as long as they're the same shape, or as long as they have the same formula, they will have the same volume. So it's going to be answer choice A. Okay, answer choice A. Any questions on this one? And Perla, yay, congrats, that's exciting. I haven't gotten any emails about that, so maybe if you have an interview, you can ask about that. Because I haven't gotten anything. All right, so any questions at all? This one wasn't too bad. I think this one just had, you had to make sure you read it correctly. Cool. Next up. Can I have a volunteer read this one for us, please?
A bakery sells gourmet cake pops. Each pop is composed of a spherical ball of cake atop a paper lollipop stick. A jumbo cake pop has a diameter of 6 centimeters. What is the volume of cake in the spherical ball of cake baked for a jumbo cake pop? That's a lot of cake.
That is a lot of cake. Okay, so basically they tell us everything we need to know in this problem. We know it's a sphere because it's a cake pop, and we know the diameter is 6 inches, and we're just looking for the volume. So this one most people got correct, but let's just go through it anyways. What is the volume of a sphere? Formula for volume of a sphere. Four-thirds pi r cubed. Good. We know the diameter is 6, so we got to plug in the radius, which is going to be 3. What is 3 cubed? Three to the power of 3. 27. And I got 27 times 4 over 3. Now, technically, this question was not in the calculator section. So let's review how to do this without a calculator. How would I do 27 times 4 over 3 without a calculator? Okay, so you can do 27 times 4 and then divided by 3. But here's a little trick. You can actually do it the opposite way as well. You can do 27 divided by 3 and then multiply it by 4. You'll get the same answer. So that might be a little bit easier because then you don't have to go and do 27 times 4. 27 divided by 3, what is that? 9. So this is 4 times 9 times pi. So that gives me 36 pi centimeters cubed. Pretty simple one. Just a very basic, do you know your formula and can you do the math? Any questions on number 2? Questions going once? Questions going twice? Good, Janelle's. And that's the main thing. If you made a mistake and you didn't get it right during the test, just as long as you're understanding it after the fact, that's going to set you up for success. All right. Here's another one. So I kind of started things off with the easier questions, as you might notice. It's going to get harder and harder. Oh, Janelle, so you used surface area. Okay, I see the difference. So, and that really comes down to reading. This asks for volume. So you know it's volume, but sometimes they're not going to say they're not going to say volume. They might say like, here's the difference. So for this problem, it's cake pops, right? There's 2 ways they could have asked it. They could have said how much cake goes into making each cake pop. And we know that the cake pop is going to have cake on the inside. So if it's the inside, it's volume. But they could have also said how much frosting gets put around the cake pop, and the frosting goes on the outside, so that would have been surface area. So just be prepared, like it's not always going to say what is the volume. It's not always going to say what is the surface area. It might, might say it a different way, and you just have to figure out which one they're asking for. And then, yeah, well, and then if you memorizing the formulas is obviously the other thing that you have to make sure you do. This chapter is the heaviest one with memorization. This one, and I would say transformations is the other one that has a lot of memorization. So like topic 1 and the first topic you learned and the last topic you learned has the most memorization. Okay, here we go. Right triangle is rotated 360 around the y-axis. What solid is going to result from this rotation? This one should have been pretty easy. What do we think? An ice cream cone. Yeah, that's going to be a cone. So rotations also could be pretty easy on this test. If you get a rotation question, again, just make sure that you're reading it carefully Because if you don't read, then that's where things can go wrong. But since we read it carefully, it said it was going around the y-axis, then we know it's going to turn into a cone. What if it was the x-axis? What would happen if I rotated it around the x-axis? Try to picture it in your head and you can describe it. Would it be 2 cones? That's one possibility. What else do you guys think? No, you don't think it's going to be 2 cones? Visualize it going down and around. It's hard to visualize. Yeah, it is hard to visualize. But one way that might be helpful is to, the first thing you want to do is just reflect it. Reflect it, and then draw in the 3D, like the circles. So kind of, well, it wouldn't really be like that. It would be more like that. Yeah. Okay. So there's my circles. But this is kind of interesting because what's really happening is that this triangle goes all the way around and around, but the cone is actually empty space. So this, if you can think about it, it's like a cylinder with a cone carved out of it. Does that make sense? It would be a cylinder with an empty cone in the middle. You guys see it? Yeah. Mind-blowing, right? That's what this would be. So that would be like a very challenging question, but just be aware that it's not always going to be as easy as the one that was on the test. It might be more like you might get like a multiple choice with this type of question, and yeah, it might be a little challenging, but not that much. This is as hard as it would possibly get. The cone stabbed the cylinder. Yeah, it's like it cut right through it. Any other questions on this one? Cool. Yeah, wait, you're typing emojis, but on your computer? Where do you do that? I've noticed you're not the only one. I saw a lot of students doing that recently. Window. Oh. So you're using like the keyboard that pops up? Cool. All right, this one gets a little more challenging. This one's a lot of reading and you got to read carefully. So who wants to be our reader for this problem?
I will be the reader.
Go ahead.
I'm going to take Tyrone's spot. Okay, Tyrone. I'm going to read better than you. What? Figures A and B are three-dimensional objects. The cross-section of figure A that is parallel to its base is the same geometric shape as the cross-section of figure B that is perpendicular to figure B's base. Based on this information, which of these pairs of three-dimensional shapes could describe figure A and figure B?
Okay, so we've got 2 figures. They kind of describe them, but not really. We don't really know what type of figures they are. We're trying to figure that out. Huh, get it? Figure? Okay. Then it tells us the cross section. It talks about cross sections. So it says the cross section of figure A that is parallel to its base is the same as the cross section of figure B that is perpendicular to figure B's base. So they have a lot of different options here, and you really have to either visualize it in your head as best as you can, or you can draw it out and try and see which ones are going to match. As long as you remember, for figure A, it's parallel. For figure B, it's going to be perpendicular. So let's think about a rectangular prism. If you have a rectangular prism, such as this one, and you cut it, like it says, parallel to its base, what type of shape am I going to have if I cut it parallel to the base? What would the cross section be that is parallel to the base? A rectangle, yeah. If you cut this guy parallel to the base, you will have a rectangle on the inside. Okay, there's my rectangle. So parallel, rectangle. Then square pyramid, square pyramid. Hold on, let me do it better. Square pyramid, cutting it perpendicular to the base. Perpendicular to the base, what type of shape am I going to get on my pyramid? And let's say it goes through the apex. So perpendicular and through the apex, what type of shape do I get? Janelle's and Jalen's, wait, Janelle's, hold on. Now everyone's changing their minds. If I slice this pyramid straight down, Perla agrees with triangle. So Tyrone, Jalen, and Perla all say triangle. That is exactly what you'll get. You will get a triangle. So are these going to have the same shape? No, they are not. It all comes down to reading. Okay, so because again, figure A, you're cutting it parallel to the base. Figure B, you're cutting it perpendicular to the base. So we got to try each situation out. A is out. Okay, B. Figure A is a rectangular prism. We'll keep that the same. Figure B now is going to be a cylinder. Okay, and I'm cutting this cylinder perpendicular. Perpendicular. So here we go. If I cut into the cylinder perpendicularly, what type of shape am I going to get? Rectangle, do we agree, guys? Or are we just going to be talking about food? Okay, we agree. Good. That is exactly what we get. So if I cut into this over here, okay, not my best drawing, but there you go. It would indeed be a rectangle. So are they the same shape? Yes, they are. We get answer choice B. They are the same shape. You get a rectangle, and here you get a rectangle as well. Now, since I have this guy over here, I might as well look at answer choice D just to show you. So for answer choice D, if I had a cone for figure A, and I'm cutting it parallel to the base, what shape would that be? Good, Tyrone. Yeah, it would be a circle. So, hold on, that looks like it's slanted. Guys, this is so hard to do. Okay. Yeah. So something like that, but yeah, if it's parallel, it would be a circle. So those would not match. So D is also not good. And then finally, cone and square pyramid, that's definitely not going to match either, because like we said, square pyramid gives you a triangle, and then this cone would give you a circle. So this one's very, you had to really either visualize things as best as you could, draw it out as best as you could, read everything carefully. This problem had a lot of tricky parts to it. So take a look at it, see if you have any questions for me on this one. So I'm looking now because I just wanted to double check. And on this question, the percentage was, let's see, 3 people got it right, 3 people got it wrong. So definitely was a little bit trickier. Janelle's, do you have a question? Okay. All right. Moving right along. 4 shapes are listed below. Which of these are possible cross sections of a cube? Did I include this one? I don't think I included this one on the actual test. No, I took it out. Yeah, I took this one out. Because this question kind of blew my mind, I'm not gonna lie. I didn't teach this, so I didn't realize I had to teach it until I saw it. But I'm gonna show you a video. Because I know I didn't teach this during class, so definitely did not want to include that on the test, but we're gonna learn it now. So before I go ahead and show you the video, just look at these and start making a prediction for which one you think it's gonna be. And then once we watch the video, we'll see if your predictions change. So which of these are possible cross sections of a cube? Think about it for about 30 seconds, try to visualize it, and then we'll watch the video and see if we learn something new. All right, now you can put your prediction in the chat privately. I want to see everyone's prediction. Which answer choice do you think it's going to be? Then we'll watch the video and then we'll come back and see for real. Send it in the chat. Okay, Emily sent me her prediction. Perla sent me her prediction. Janelle sent me her prediction. Tyrone sent me his prediction. Still waiting on Daniel, Jalen, and Rios. Go ahead and send me your predictions, guys. Thank you, Tyrone. Jalen, Daniel, Rios, thank you. All right, here we go. Let me share this video. This is Khan Academy, by the way. Jalen, just send me a prediction.
What I want to do in this video is explore the types of two-dimensional shapes we can construct by taking planar slices of cubes. So what am I talking about? Well, let's say we wanted to construct a square. How could we slice a cube with a plane to get the intersection of this cube and that plane to be a square? Well, imagine if that plane were to cut just like this. A square is maybe the most obvious one. So it cuts the top right over there. It cuts the top right over there. It cuts this side right over here. Cuts this side right over here. It cuts this side, I guess in the back, if it's a glass cube, you'd be able to see it, right over there, dotted line. And then it cuts this right over here. So you can imagine a plane that did this. And if I wanted to draw the broader plane, I could draw it like this. Let me see if I can do an adequate job.
He does a better job than I do. He's really good at this.
You say part of the plane that is cutting this cube. It could look something like this. And I could even color in the part of the plane that you could actually see if the cube were opaque, if you couldn't see through it. But if you could see it through it, you would see this dotted line, and the plane would look like that. So a square is a pretty straightforward thing to get if you're doing a planar slice of a cube. But what about a rectangle? How can you get that? And at any point, I encourage you, pause the video and try to think about it on your own. How can you get these shapes that I'm talking about? Well, a rectangle you can actually cut like this. So if you cut this side like this, and then cut that side like that, and then you cut this side like that. I think you see where this is going. This side like that. And then you cut the bottom right over there. Then the intersection of the plane that you're cutting with. So the intersection, let's see, this could be the plane that I'm actually cutting with. So the intersection of the plane that I'm cutting with and my cube is going to be a rectangle. So it might look like this. And once again, let me shade in the stuff. If you kind of view this, if you imagine the plane is like one of those huge blades that magicians use to saw people in half, or pretend like or give us the illusion of sawing people in half, it might look something like this. Okay, so you're like, okay, I that's not so hard to digest, that I can, if I intersect a plane with a cube, I can get a square, I could get a rectangle. But what about triangles? Well, once again, and pause the video if you think you can figure it out. Triangle's not so bad. You could cut this side right over here, this side right over here, and this side right over here. And then and of course I could keep drawing the plane, but I think you get the idea. This would be a triangle, and there's different types of triangles that you can construct. You can construct an equilateral triangle. So as long as this cut is the same length as this cut right over here, is the same length as the length that it intersects on this face of the cube, that's going to be an equilateral triangle. If you pushed this point out more, actually let me do that in a different color. If you pushed it out more, you're going to have an isosceles triangle. If you were to bring this point really, really, really close, like here, you would approach having a right angle, but it wouldn't be quite a right angle. You'd still have, these angles would still be less than 90 degrees. You can approach 90 degrees. So you can't quite have exactly a right angle. And so you can't get to 90 degrees. You're definitely not going to get to 91 degrees. So you're actually not going to be able to do an obtuse triangle either. But you can do an equilateral, you can do an isosceles, you can do scalene triangles. I guess you could say you could do the different types of acute triangles. But now let's do some really interesting things. Can you get a pentagon by slicing a cube with a plane? And I really want you to pause the video and think about it here, because that's just a fun to think about. How can you get a pentagon by slicing a cube with a plane? All right, so here I go. This is how you can get a pentagon by slicing a cube with a plane. Imagine slicing the top. Let me do it a little bit different. So imagine slicing the top right over there. So we imagine slicing the top like this. Then imagine slicing this backside. Imagine slicing this backside like that. This backside that you can't see quite like that. Now you slice this side right over here like this, and then you slice this side right over here like this. This could be, and like if I wanted to draw, well, the plane, it maybe won't be so obvious if I try to draw the plane, but you get the actual idea. If I slice this, the right angle, not at a right angle, at a right angle. Actually, I shouldn't use it with a right angle. That'll confuse everything. If I slice it in the proper angle, then the intersection of my plane and my cube is going to be this pentagon right over here. Now let's up the stakes something. Let's up the stakes even more. What about a hexagon? Can I slice a cube in a way with a two-dimensional plane to get the intersection of the plane and the cube being a hexagon? Well, as you can imagine, I wouldn't have asked you the question unless I could. So let's see if we can do it. So if we slice this right over there, if we slice this bottom piece right over there, and then you slice this backside like that, you slice this backside like that, and then you slice this side that we can see right over there, and then this side that we can see right over there. This side, I could have written it much straighter. So hopefully you get the idea. I can slice this cube so that I can actually get a hexagon. So hopefully this gives you a better appreciation for what you can actually do with a cube, especially if you're busy slicing it with large planar planes or large planar blades in some way. There's actually more to a cube than maybe you might have imagined in the past. And one way to think about it is there are 6 sides to a cube. And so, or 6 surfaces to a cube. So you can cut as many as 6 of the surfaces when you intersect it with the plane. And every time you cut into one of those surfaces, it forms a side. So here we're cutting into 4 sides. Here we're cutting into 4 surfaces or 4 sides. Here we're cutting into 3. Here we're cutting into 5. We're not cutting into the bottom of the cube here. And here we're cutting into all 6 of the sides, all 6 of the surfaces, of the faces of this cube.
So, whose mind is blown? Pretty interesting stuff. No, well, you know what? No more Khan Academy homework, but once in a while, they have useful videos. So at the end of the day, answer choice D was the correct answer. All of these are possible. We can do a triangle, parallelogram. That also counts because rectangles and squares are both types of parallelograms, right? Pentagon, like we saw, and hexagon as well. So all 4 are possible. Pretty cool. Now that's something that you had a feeling because, yeah, with these types of problems, if it's got 4 possibilities, a lot of times it's all 4 of them. And that's just something to keep in mind. And I think the way that he said it at the end was the easiest way to remember. There's 6 sides on a cube. So there's up to 6 sides that you can slice into. So you can have all the way up to a hexagon. And if you have trouble remembering that, just remember you can have up to a hexagon, but nothing more than 6. So that shouldn't be too bad to remember. Any questions on this one? Cool. All right. Now we get into the harder and harder questions. Who would like to read this one, please? Because my voice is really going away today.
My voice is going away too.
So that's a no from you?
Yeah.
Okay. Anyone else?
This has my name on it.
Go ahead.
A building in the shape of a rectangular prism needs to be painted. Some facts about the building are shown below. The building has a width of 50 feet, a length of 80 feet, and a height of 120 feet. There are 60 windows on each lateral face of the building. Each window is a square measuring 5 feet on a side. Using this information, which expression represents the total lateral surface area in square feet that needs to be painted?
Okay, so we have a rectangular prism building. It has windows. So when we paint the building, we're going to paint everything except for the windows. And when you paint a building, what else are you not going to paint?
The floor and the interior.
The floor, the interior. What about the roof? Do you need to paint the roof? No. Okay, so we're just looking at the 4 sides of this rectangular prism. So I'm going to draw it out, as I always do. If Jalen thought that the Khan Academy video was poorly drawn, then he's going to definitely judge my drawing. Yeah, let me fix that. I could
No,
do
you're
better.
Picasso.
Thank you. Okay, that's a little bit better. But Picasso draws, never mind. Okay.
He draws people.
Yeah, but he draws things not in the correct proportions. So if you're telling me I'm Picasso, you're telling me I'm bad at drawing things proportionately.
No, a better version of Picasso.
Oh, okay. So, okay, here we go. Width is 50 feet. Length is 80 feet. I guess technically this would be the length. Doesn't really matter. But I drew it a little bit longer. 80 feet, 50 feet. Height is 120 feet. 60 windows on each surface, each lateral surface. So there's going to be 60 windows here, 60 windows here, 60 on the back, and 60 on this invisible side. So a lot of windows. How many in total is that going to be? How many in total? Read it again. It says 60 on each side. How many sides? 4 sides, 60 windows on each side. That's going to be 4 times 60, which, like Janelle said, is 240. That's the number of windows. Then it tells us that each window is a square that measures 5 feet on a side. Well, if it's a square and it's 5 feet on one side, how many feet is it on the other sides? Also 5, it's a square. So what would be the area of this window? 25. 5 squared, which is 25. So if I want to take the area of all the windows, then I'm looking at 4 times 60 times 5 to the power of 2. So right here, in this one and this one, there we have the area of each window. Now, why am I subtracting that? Why is that being taken away? Because that's what you're not going to paint, exactly. So what am I painting? I'm painting the area of the lateral area of this building minus the area of each window. So I need to take into account the area and then take away each of the windows. So for that reason, B and D are good so far. A and C are out the window because they didn't, what did they do? They didn't multiply by 4. This would be the area of only one side of windows. We have to multiply by 4. Then, well, let's figure out what is the surface area of the lateral, okay, the lateral part of this building. So not including the top and the bottom, what would be what would I be adding up to find the surface area? Not including the top or the bottom. The sides and the front and the back, yeah. So the surface area would be 2 times this guy right here. So let me highlight that one in green. So 2 times that, which would be what? What would be the area in green? $120. How'd you get that? Just 120? Good. 120 times 80, length times width. So 2 of those, because you have the front and the back, and then the 2 sides would be this one. What would be the area of that? I'm gonna move this down here. 50 times 120, good, but we have 2 of those. So 2 times 50 times 120 and 2 times 180 times 120 times 80. So 2 of these front and back, 2 of these side and side. We're not including the top or the bottom. So let's take a look. 2 times 180 times 2 times 120 times 80, 2 times 120 times 50. There it is. It's answer choice B. What did they do here? They did this right here would have been the top and the bottom. Which we did not need. All right, so if they included that, that was automatically out. And B was the only one with all of the correct information. So again, for this one, let me see. 2 people got it right. Everybody else got this one wrong. I had 2 people choose A. I had 2 people choose D. So 2 people who included the top and the bottom, and then 2 people who forgot that there were 4 sides on the building that were covered in windows. So this needed to be multiplied by 4 because there's windows on all 4 sides. Very important to make sure that you, in this type of question especially, the thing you got to do is figure out, okay, where are each of these numbers coming from? And how do I match that with what I actually need to find? Questions on this one? Going once. Going twice. Cool. Next up. Okay, this one wasn't too bad. We had to find the volume of the whole model. So volume of, we're adding together the volume of cone and hemisphere. And we just had to make sure we remembered those formulas. So what's the volume of a cone? One-third base times height. Volume of a hemisphere? Two-thirds, good. 2/3 pi r cubed. Because a sphere is 4/3, hemisphere is going to be 2/3. And the base of my cone is a circle. So this is 1/3 pi r squared h plus 2/3 pi r cubed. Pretty simple. We're just going to plug everything in. And for this question, technically, this would have been on the no calculator section. Or maybe, oh no, this one was in the calculator section. Okay, well, let's try to do it without a calculator because we can. So 1/3. Radius is 3. Height is 10. And again, the radius is 3. 3 to the power of 2 is 9. What's 9 times 1/3? Nine times 1/3. Three. 9 divided by 3 is 3. So 3 times 10 pi plus 2/3 times, this is 27 pi. 3 times 10, that's 30. And remember, you can do this one of two ways. You can either multiply by 2 and then divide by 3, or you can divide by 3 and then multiply by 2. And it might be easier to divide first. So what do I get for 27 times 2/3? 18. 30 plus 18, I get 48 pi. Answer choice A. So for this one, let's see, 2 people got it right, 4 people got it wrong. So I don't know, this one, to me, this one's something that everyone should have been pretty solid with. So let's talk about it. Let's see what's going on in this problem. Where could we have gone wrong? What mistakes maybe were made? What do you guys think? So on this one, let me see, hold on. Janelle's, let me answer your, I have to go back for a second. Give me 1 second. It's loading. Janelle's, you got that one right. All right, so yeah, those of you who got this one wrong, I know that one person got it right the second time around, that's good. But everybody else, make sure that you understand where all of these numbers came from. Make sure that those formulas are memorized. If those are not memorized by now, you have 1 month to make sure that they're memorized, because they're not going to give you a nice sheet of paper with all those formulas on it. You got to do it yourself. 1 month indeed. Yep. 30 days. I think technically 29 days. No questions? Okay, going ahead. Here's another volume 1. So, okay, the entrance to the Louvre Museum in Paris is a square-based pyramid. The volume, they give us the volume, and they give us the height, and we need to know what is the length of each side of the square. So we need to know the volume formula. What is the volume formula for a pyramid? Volume of a pyramid, anyone? Going once? 1/3? 1/3 what? 1/3 base times height, yeah. But what's the base of this pyramid? It's a square. So what's the base area of a square? S squared. So remember, B stands for base area. So when I write B, you have to remember that you still need to figure out what that actually is. And it depends on the base. For a square pyramid, it's a square. For a cylinder, it would be a circle. For a cone, it would be a circle. So you have to always think, okay, what is the base? It's a square, so that's the formula for the area. Then I plug everything in, so my volume is 9,039. I don't know the side length, that's what I'm trying to find, but the height is 21.6. And I'm gonna solve for S. I need to find the side length. So what can I do to both sides of this? Times 3, good. You can have a calculator on this problem. 3 times 9,039 gives me 27,117. Now what? Not yet. Not yet. I can't do it yet. I got something else here I got to deal with. Yeah. Got to divide first. And then when you do that, 21.6, you get about 12,000. I mean, 1,255. Now we can take the square root. And what do we get? Square root of 1,255.4. Anyone? Square root, calculator, easy. Where's the button? Find the square root button. There we go, Emily, about 35.4. So answer choice B. So with this question, it was just a matter of, remembering the formula, plugging everything in, and this time you're not looking for the volume, you have to solve for this, for the side length. Questions on number 3. No, ma'am. Going once. Going twice. Okay, last two problems. So this one was the one I warned you guys. Number 1 and number 2 were both just lengthy. They took a long time. But this one in particular, I felt like it wasn't like the hardest thing in the world, but it was difficult to take time and do it. Yeah. So let's read this carefully. Let's make sure we know what we're doing. It says that the table below is the population and the areas for the 10 US states having the least population density. Which of these countries has a population density that's less than the average population density of the 10 US states listed in the table? So we need to find the average population density of these 10 states. Well, do we know the population density yet? We got to find it. We know the area and we know the population. So what we need to go through and do is calculate the population density. Now, population density is something that you should have already remembered, which is just going to be the population over the area. So we're just going through and we're dividing. 730 divided by 572, you get an answer. 576 divided by 97, you get an answer, and so on. So what I want to do, let's see if we can do this. Let's split up the work. Here, let me make this a little bit less thick. So let me go through it and tell you now which one you're each going to do. There's 10 states and there's 7 of you here. So some of you are going to do it once, some of you twice. Perla, first 2, just going in order. Emily, second 2. Janelle's the third 2. Daniel, you're doing Idaho. Tyrone, you're doing Nebraska. Jalen, you're doing Nevada. And Rios, you're doing Utah. Just go ahead and divide. Population divided by area. And put your answer in the chat, or you can even type it. You can annotate the screen if you want.
What am I again? Idaho?
You are Idaho, yes.
Okay.
Wait, miss, which one was I?
Tyrone, I think you were Nebraska. Okay, Rio's got his already. 34.8. Janelli, South Dakota, 12.07. $24.1 for Nebraska. New Mexico, 17.23. Daniel got Idaho, 19.19. Oh, Perla, I didn't even see yours. 1.3. Wait, Perla, which order is that? Alaska and then, okay. So 1.3 and 5.94. And then Emily, you got 6.9 and 10.1. I'm just missing Nevada. Jalen.
I did something completely different. It's already there. Hold on.
Okay, just divide. Population divided by area. Then, once we got Jalen's answer, we have to find the average. How do I find the average of something? You're adding them all up and then you're dividing by 10 because there's 10 that we put in. So let's go ahead and do that. What do we got, Jalen? 25.08. 25.08.
I got that.
Looks good to me. Okay, I'll keep it zoomed in. So we're adding all of these up. Matter of fact, let me just do this. I'll put a total. Go ahead and everyone try this so that we make sure we get the same answer. Add them all up. Let me know what you get. Janelle's, I'm assuming you put your point in the wrong place, right? No? Oh, you divided by 10 already. I see. We're just doing the total so far. I haven't found the final average. Good. We all agree the total was 156.71. Cool. I don't know, Tyrone, I don't know where you got 64. Just double check. Do it again. Okay, so that's my total. Then that means my average is going to be the total divided by 10 because there were 10 states that we put in. So 156.71 divided by 10, we got 15.671. But we're not done yet, because now we need to see which of these countries has a population density that's less than 15.671. So now I got to go through and find all of these population densities, doing the same exact thing. Population divided by area. You had to make sure that you were doing it in the correct direction, because this is population and this is area. So let's just go straight down. Rios, you do A. Jalen, you do B. Tyrone, you do C. Daniel, D. And all the girls do E, since you guys all had to do 2 of them last time. So Alejandro, A. Jalen, B. Tyrone, C. Daniel, D. D for Daniel. And all the girls do E.
You said I do B, right?
Mm-hmm. Good. Jalen, Janelle's and Perla got the same thing for E, 236.61. So Turkey, a little bit too big for Turkey. That one's out. All right, Laos. Rios just got back to me with 71.47. Also too high. We're looking for anything under. Tyrone, good. Canada, 9.27. That one's good. That one's under 15.6. Jalen, you got 32.55. Good. Saudi Arabia is out. And who am I missing? Daniel? D for Daniel. Iceland. What did we get for that one?
Okay, I had to switch my. What?
You good?
Canada. Wait, no, Iceland.
Iceland.
I don't know.
Remember that you're doing population divided by area. So 299,388 divided by 38,707.
Oh.
It's okay. Take your time. I know you guys can do it on your own if you want, but I want Daniel to have an opportunity. What you got?
Wait, I typed it in wrong.
Oh no.
I'm blocking the freaking screen. Come on.
Just move the chat over. Jalen's
I got
playing Hangman. You got it. Yeah, 7.71. 73, which is good. That one's under 15.6. So after all that work, C and D were the only ones that were under the average of all these states. So this problem, like I said, no part of it was hard. You just were dividing a bunch of things and then adding and then dividing again. But figuring out what you needed to do and then taking the time to do all of that, definitely time consuming. Questions on this one? And then also making sure you don't make mistakes, right? There's all these numbers. You had to make sure you didn't make any mistakes. Yeah, good teamwork, guys, really. Nice job. Cool. Last question. Save another time consuming one for last. Who would like to tell me about store trash? Who can read this problem for us? Yep, this one was tough. Did anyone get it right? Let me check. Yes, 2 people. Anyone want to read? Please save my voice.
I'll read.
Thank you.
Ford Trash manufactures trash cans that are open at the top and do not have lids. The company's engineers are designing a trash can that has a total volume of 7.85 feet cubed. They are deciding between a rectangular prism-shaped trash can with base dimensions of 1.5 times 2 feet and a cylindrical trash can with a base area of 3.14 feet squared. The material used to manufacture the trash can costs $3.60 per square foot. Which trash can design will cost the company less to manufacture and by approximately how much?
Okay. So a lot of info, no pictures, a lot to work with, right? So we know that there's trash cans they're just open at the top. So that's just a little bit helpful for you to calculate things. There's 2 possibilities. There's going to be a rectangular prism shaped trash can. So something like this. And remember, it's open at the top. So only the sides would be colored in. And the other one would be cylindrical. Same thing, it's open at the top. So only the sides, and of course the bottom as well. Okay. Then they give us a lot of information. They say that the volume for both of these, the volume is 7.85. And then they tell us that some of the dimensions. So the rectangular prism has the base dimensions are 1.5 by 2. So 1.5 and 2. And the cylindrical one has a base area. So base area of 3.14. The material used to manufacture the trash cans costs $3.60 per square foot. Okay. And then they're asking which one's going to be cheaper. So there's a lot of information, right? But at the end of the day, they're asking us about the material used to manufacture the trash cans. Is that volume or is that surface area? That is the surface area, because they're not asking us how much trash fits inside. They're asking us about the material that they used to make the trash cans. So that's all of the outside surface. And in order to figure that out, well, we need to know the surface area of each of these, but we're still missing some information. We don't know the height. of either of them. We don't know the radius. We're gonna need that. So we gotta figure some stuff out, but luckily we do know the volume. And since we know the volume, we can solve for the height. So let's start with the rectangular one. I'm gonna make this a little smaller. We'll work with that later. I'll move it over here. Since the volume is 7.85, we know that volume is length times width times height. We can solve and get the height. So this would be, the length is 2, the height, or the width is 1.5. I don't know the height, but I can find it. 2 times 1.5 is 3. If I divide both sides by 3, what do I get? I get about 2.6. Agree? Just check your work for me too, because I'm doing it quickly, but I just want to make sure I'm doing it right. What's going on? Okay, where's Mr. St. Rose? Can he come on so that I can talk to him? No, you can't. No, you can't. I'm the teacher. I say no. Y'all have to stay. I need to finish this problem. I know he has something to give you guys, but he can give it to you at any point, and right now we're reviewing. So I'm gonna keep going. I got the height. Now I have everything that I need. Now I need to know the surface area of this trash can, not counting the top. So if I'm not counting the top, I have the front, the back, the 2 sides, and the bottom. So the front and the back, that's going to be 2 times 2.6 times 2, because it's height times length. The 2 sides is going to be 2 times 1.5 times 2.6. So I have the front and the back. I have the 2 sides. Now I just need the bottom. The bottom's going to be 2 times 1.5. I got to add all this up. Here we go. 2 times 2 is 4. 4 times 2.6, I get 10.4. Then over here, 1.5 times 2.6 times 2, I get 7.8. And then 2 times 1.5 is 3. So the surface area would be 10.4 plus 7.8 plus 3, that's 21.2. Surface area of this prism, but not counting the top. And finally, we know that it costs $3.60 per square foot. So the cost is going to be 21.2 times that price. So I get $76.32. So that's the cost to manufacture this trash can. $76.32. So I'm going to write that down up top. Then I have this guy, my cylinder. Kind of similar situation. I know some information, but I don't know all the information. Okay. But I do know that, I do know that volume of a cylinder is base times height. And I know the base area is 3.14. So I can find the height. All I gotta do is divide. So 7.85 divided by 3.14, I get 2.5. So they have approximately the same height. Now, the base area was 3.14, and I can use that to find the radius. If the base area is 3.14 and pi equals 3.14, then I can divide by 3.14 on both sides. And what do I get? Oh, the bell's about to ring. I get 1. So the radius is 1. And then you have to find the surface area. Long story short, surface area would be pi RL plus pi r squared. So that would be 3.14 times 1 times 2.5 plus 3.14 times 1 squared. So you get 2.5 times 3.14, 7.85 plus 3.14. I know, we're almost done. 10.99. Then you got to multiply that by 3.60. So the price for this guy is $39.56. And when you subtract, wait, I might have done something wrong. Pi r h 2.5. I don't know. I think I did something wrong. Long story short, it's answer choice B. I think tomorrow I'll spend more time at the end to go over this one, because I do think I rushed it at the end. But yeah, this one was a lot of math. Congrats to those who got it right. Tomorrow we begin on day 1 of actually reviewing everything, starting with transformations. So look forward to that, and I will see you then. Bye, everybody.
Bye,
Have a great
man.
rest of your day. Bye.
I'm gonna get some cereal, so I'm gonna do.